Greetings of the day. Today we will discuss database design steps. How we can design database. First, database is a collection of related data. Data is in the form of tables. We can design database using several steps. In this class, we will see how to design the database. What are the different steps to design the database? Database is a collection of related data. Data is in the form of tables. Designing a database involves several steps to ensure that it efficiently stores and manages data according to the requirements of the system or application. Here is a general outline of the steps involved in designing a database. That is requirement analysis, conceptual design, logical design, next schema refinement, that is nothing but normalization, schema refinement or normalization, next physical design, next finally implementation or application security level design. These are the 6 steps for database design. First step is the requirement analysis. Requirement analysis is nothing but to create a database, first we have to understand what type of data we need to store in the database. What are the applications built on the database? How much space we need to store the data? What are the different operations we can apply on the data? Next, who are the users, end users of the data, who are using the data finally. So these all are the different things needed before designing the database. This is nothing but requirements gathering or requirements analysis step. In requirement analysis, we will gather the data. Database requirements for database. For example, for employee database, what data you need to store. Employee related details you need to store. Next, employee table, you are having employee related data. Project data you need. Next, employee related personal information you need. Like that, for any university management system, you need a student information you need. Next, college information you need. Next, project information or placements information, MOEs with the industries information. Next, different councils which are present in the college, those stationary requirements in the college, infrastructure requirements of the college information. These are all the different details needed for the particular database creation. For a database design, you need all things. These just the example which I discussed is a general example. In real time, we are having like that. We are having several case studies. In several case studies, we need what data we need to store, why we have to store the data, what are the applications, who are the users. Next, how you can store the data, what are the data types you are using, how much memory it is taking. These are the different things you have to take care of. That is the requirement analysis. Understand the requirements of the system and applications for which the database is being designed. This involves gathering information about data to be stored, in relationship between different types of data. That is also needed. The data which we are storing, these data are having what type of relationships among those data, and the expected usage patterns, different usage patterns, how we can expect this data can be useful finally. So these are we have to gather, these are we have to analyze before preparing a database, before designing a database. Next, conceptual design. From first step, you will get the what data to be stored, how the data is to be stored, what is the space required, all the information. In conceptual design, create a high-level conceptual model of the database focusing on entities, attributes, and relationships between entities. This step often involves techniques like entity relationship diagrams. From the first step, we will get the information, what type of data we can store, how much space required, who are the users, like that. So for these, we will design different types of ER diagrams, different types of entity relationship diagrams. So for example, for the same case study, university management system, so you need different entities like student, project, next placements, like that. You need different entities. So entity is a real world object. Any real world object is an entity. So attribute is nothing but property of an entity is nothing but attribute. For example, student is an entity. Attribute is nothing but student properties, means student features. Student roll number, student name, student age, student marks, student address, student father name, student mobile number, student email ID. These all are the attributes of the entity. Relationship. This student is an entity. Faculty is an entity. Faculty is also having different attributes like faculty ID, faculty name, faculty age, faculty salary, like the different attributes are there. So how student is related to faculty? So faculty guides student, that is the relationship between faculty and student. Faculty monitors the student. Next, student and project. Project is an entity. So for project you are having attributes like project ID, project name, project budget, like that. So which student doing which project, that is the relationship. That works on is a relationship between student and project. Student is an entity, project is an entity, works on is a relationship between student and project. For example, some CSC student works on this project, some student CSBS students works on this project, some AML student works on this project, some ADS student works on this project. Different departments of students, different students works on different projects. So which student works on which projects from which date, the data we can get by using ER diagrams. Like that, any data for any case study we can draw ER diagrams. ER diagrams give the clear picture of the data in diagrammatic format. So logical design. Logical design is nothing but the ER diagrams which you created. For all those ER diagrams, you are creating tables. In ER diagram, each entity can be converted into a table. Each relationship can be converted into a table. Like that, all these entities relationships are converted into tables. Everything, the entire ER diagram can be converted into different tables. So that is nothing but logical design. Logical design is nothing but conversion of that ER diagram into tables, that ER model into relational model. So relational model is nothing but completely data is in the form of tables. So the conversion from ER model to relational model, ER diagram to tables is nothing but the logical design. Translate the conceptual model into a logical model that can be implemented using specific database management system. This involves defining tables, columns, data types, keys, indexes, and constraints. So while creating tables, you need to represent all these things. We have to create columns for student table, student ID, student name, student age, student marks, like that different columns you need. Different data types. For a student roll number, you are having varchar. It contains numbers and alphabets combination. For example, for our college roll numbers, student IDs, if you take 222 211 A 3202, like that. No? That is alphabets and characters numerical combination. That's why varchar is the data type. Student name, that is a varchar we can take. Age is the integer format. Next, address, that is a varchar, combination of characters and numericals. Like that, for each and every column, you need to represent, you need to specify data type. Next, keys. When you need to maintain a key. For a student table, you need to maintain a key to identify uniquely a student. Usually, we use the roll number. Roll number is the thing which we can easily identify a student. For uniquely identifying student, we will use the roll number. That is the primary key of the student table. For project table, PID is the project ID is the primary key. Like that, for every table, you need to represent a key. You need to specify a key. Key constraint is nothing but it is a condition we are specifying to identify the column uniquely. That is nothing but to identify each and every person uniquely, you are having the roll number. So each and every project uniquely identification, you are having the project ID. Like that, for different entities, so for every entity, you have to specify some key. Uniquely identify that attribute, what you need. So that what attribute you need to uniquely identify the each and every object, each and every student identification, what you will use, the student roll number you will use, each and every project identification, project ID you will use, each and every customer, if you need to address, identify the customer ID you can use. Like that, for every entity, any entity, you need to maintain a key for unique identification. Either it is a customer or employee or student or it is a book, whatever it may be. For any entity, unique identification, you will use the keys. Indexes. Too many tables are there, then what you will use? You can use the index. Index is a data structure that allows fast retrieval of data. So in a database, student database, you are having 100 number of tables. Then gathering the data is easy with the maintaining index. Maintaining index to the tables, it is easy to go to the particular table and collect the data from the table. Easy. Constraints. You need different constraints you can specify in real time while creating the table. For example, student roll number should not be 0. Student age should not be 0. Obviously, age means so for any student you are having age of 17 at least. You can put a constraint like that. Student age, while inserting the data, just you can write a check, or creating table, you can write just a check of age greater than 17. Age greater than 17, then only he or she can study in engineering. So that's why with 17 age greater than or equal to 17, then only the data can be taken by the system. So if you enter 13, 14, 15 like that, it will not take the data. So that is the logical design step. Next, normalization. Normalization is nothing but step-by-step process of reducing the redundancy. So these tables are having the redundancy problem. So this problem can be reduced. These problems can be solved by using normalization concept. Step by step, you will reduce the repeated values. You will just eliminate. Next, physical design. So physical storage structures and access methods are for the database. This includes decisions about storage, allocation, indexing, strategies, partitioning, and clustering. So these are all the different, how physically you can store the data. So after completion of normalization, you will get the data that is not having any type of problems. So the data is completely pure data. That means it is not having any inconsistent values, any erroneous values, any mistake values, any repeated values. So these all can be eliminated. So then easily you can store the data. So you can combine the tables, you can maintain the data. That is nothing but the physical design. Final implementation is nothing but application and security level design. So which users are applying this, using this data finally, and how we are providing security to the data, what are the different security methods we are using. These are all things we will take care in the 6th step. That is nothing but implementation or application security level design. So these are the different database design steps to be taken to create a database, to design a database in real time. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.